Hello everyone in the crowd. Thank you very much for coming along. We're going to disturb your peace for a few moments and talk about SUSE OpenStack Cloud. So, I work for SUSE. I'm Simon Briggs. I work out the Europe, Middle East and African region. And I'm very thankful to have come over to Vancouver, see this beautiful view, and to present to you today. So, what we're not going to do is a load of marketing slides or information for you today. We're actually just going to drive our cloud and describe how the techniques work for driving our environment. What we're going to use to demonstrate the power of SUSE OpenStack Cloud is actually deploy some of our other technology on top of SUSE OpenStack Cloud to give you a reference point of how easy it is to accommodate certain capabilities. So yesterday at the keynote, there was a lot of conversation around containers. There was a lot of conversation around how integration of OpenStack into other technology stacks is a vital capability for us moving forward. And SUSE OpenStack Cloud very definitely is an enabler for that. And because of that, what we'll do is present how we build out, via software definition, a containers Kubernetes management environment. And then we'll go a step further. I'll hand over to my colleague here, Cameron Cedar from the North American team, and he will drive a demonstration of a containers-based cloud Foundry solution that SUSE deliver in our containers application platform, and he'll show you how that delivers on top of our containers layer that I'll build. So that's a quick description, and I've already loaded my interface into Horizon here.
That's the good stuff.
Absolutely.
That's the good stuff.
I've obviously logged in, so I'm trusting that most of you are familiar with OpenStack at this point. I'll take off my stupid glasses because I can't see anything. So I've got old eyes. Under here is grey hair. I assure you. So let's go to our script. So within SUSE OpenStack Cloud, we delivered to you our capabilities like our containers Kubernetes management layer. And that comes with a full heat script, which describes exactly the environment that you want to deploy. You just pick it up as you would any other heat script in OpenStack. There is an environment file to define the variables, and you just drive it, as you would expect to drive any other heat stack. In here, I give it a quick name, obviously. Vancouver seems a reasonable name for being here. I hope I haven't spelt it wrong. And I have to authenticate, as you would expect. I pick up my image, which is a pre-built QCOW2 image that SUSE delivers to you as our customer. And then I give it a flavor. Now, the actual Kubernetes management platform that we've got here, it could be delivered straight into bare metal, but we're going to do it as VM because that's just easier for our demo environment. And we just can build as many workers as we want. The workers themselves in the Kubernetes environment do take quite a few resources, and that's why we've got the medium build. And it's as simple as driving that heat script down into our cloud. Obviously, this bit I like to present because it's nice and interactive, so I'll do the little wigglies for you there. And obviously, they come up green, which is nice. That means my script is working. If it comes up red, I will panic and have a moment in front of you. Are the demo gods with me today? We are hopeful. It did work a few minutes ago, so hopefully it's still running. Okay, so those assets, those virtual assets from our software definition being driven on top of our SUSE OpenStack Cloud. It's probably apt for me to explain that the SUSE OpenStack Cloud we're working on at the moment is over in Provo, in Salt Lake. If you know SUSE's heritage, there's a reason why. It's down in there, but our demo cloud resides in Provo, near Salt Lake, and it allows us to work remotely across the globe as a sales engineering team. Myself and Cameron use it. And in that cloud now, we have some instances working, obviously. All my assets are green. And there you can see the virtual resources that I've got working in my cloud. The keen-eyed amongst you will have noticed there's an admin node. So within our environment, our containers management layer, we have an administration node, then we have a master node, and then the workers which actually deliver the Kubernetes environment for us. Our administration node is up at a login, so I know that I can now go to the floating IP address giving me public access over the internet of that node. If I select that IP, copy across onto, and Control V, and then we have nothing. Okay, right. Have I miscopied at all? It's probably just working through. I was delaying for you to give us a bit of time. Sorry? Okay, I don't think it's a Wi-Fi problem. I think it's just the speed of the refresh on the... It's coming up, obviously, it's loading quite a bit of stuff. When we were playing with this earlier, it did work in a reasonable time frame. So give me a second. Yay, there's something there. My relief is extreme. Thank you for bearing with me. I thought the demo gods were bullying me then. Right, so immediately there from one software definition, one heat script, just click of a button, you've then got the environment ready to fully install our containers as a service platform. Okay, from SUSE. I'm going to hand over now to Cameron, who's going to walk you through what you could do on top of that environment once that infrastructure is built for you. So thanks, Cam.
Perfect, perfect. Let's add some awesome on top of that. We've got, so the initialization process on this admin node takes a few minutes because it's spinning up containers and it's got to get things ready. So the initialization there took a little bit. Slows down a little bit under virtual machines. I'm going to start out with something fun. This is a game we put together that's running in the cloud on this particular environment. I'm not particularly great at this game, but you could grab that URL up there and play it if you wanted to on your phones. But I'm going to use this application as something running in the cloud. And to start out, just to show where this is running and how it's running, let's look at the details behind that. So my colleague spun up Container as a Service platform, and this environment is running on top of Container as a Service platform from SUSE running on OpenStack. If we go over here and take a look at the instances, this particular environment is under a different Container as a Service platform that's running under the same cloud. Here's all of the nodes as you see here. It's got several master nodes for Kubernetes and several worker nodes for this environment that are already set up and running. If I switch quickly over to the command line and run some kubectl commands, we can show all the pods that are running there. If we scroll up just slightly, we have a namespace called SCF, which is SUSE Cloud Foundry, which is part of our cloud application platform that is currently running on top of our Container as a Service platform. So we have both Container as a Service platform running on top of OpenStack, and then on top of that, running as containers, we have our cloud application platform, which is Cloud Foundry based. So we have all of those containers running there. Switching back to the web browser, let's go ahead and see the Cloud Foundry dashboard. I'm going to move over to the Cloud Foundry dashboard, which is actually driving a lot of this workload, this dizzy lizard that we just showed. I'll quickly log in. And through this dashboard, we can show the applications that are currently running. I've got my Dizzy Lizard application. It's actually running 8 instances in the Cloud Foundry So we can scale those up and scale them down how we see fit. So what's really nice about this dashboard is that you can actually deploy many different types of applications through the Cloud Foundry interface. And we have things, if we go over here and take a look at the Cloud Foundry, we have build packs. Build packs can give you the ability to build out any type of application that you might have, whether it's based on Ruby, whether it's based on Node.js or Java. We have build packs available for you to run any different type of application that you desire there. And you come with all these build packs preloaded into the environment. But it's all well defined in a configuration out on a GitHub. In this particular case, if we go out to github.com, cedar, and it's, I think it's Clumsy Bird is where I forked it from and then made those changes. So Clumsy Bird is where the source is. That's the original. So we just kind of reskinned this particular application and put a lizard in there, and instead of a bird. And so we forked that and built those bits into it. More importantly, from this particular GitHub, there's a manifest file. This manifest file is pulled in by Cloud Foundry from GitHub. This is a very basic manifest file, but it gives everything that you need to know in order to build this environment. And in this particular one here, it's got the build pack, such as Node.js, which is required to run this application, and the amount of memory that it requires to run this application in that container. And then we also have the number of instances. I could do a pull request to change the number of instances and then relaunch the application, and it would scale it up or scale it down depending on what the number of instances was. If we go quickly switch back on over to the Cloud Foundry application here, we can go ahead and deploy an application. Now, first of all, let's go ahead and stop this one. We'll stop Dizzy Lizard. I am going to, yep, we'll refresh. You should be, all 8 of them are now offline. Let's go ahead and deploy an application. We'll select this namespace as SUSE. We're going to put in my GitHub project, Clumsy Bird, and that should pull right in. And at this point in time, it's going to pick up that manifest file. So I hit deploy, it's going to pick up the manifest file, and right now it's prepping everything to create a container. And it's doing the work now to take that build pack, Node.js, and add some more characteristics to the build pack, and then containerize it. And it's doing all this work for me. I don't have to touch the system. I don't have to do anything with building out a separate container or go to any container registry at all. It's building everything through this build pack. And it's dropping my code in there from GitHub. It's going to drop the Clumsy Bird code in there. Then once it's built, once it's created the container, then it's going to spin that container up and all of the instances that are defined in that manifest file. So once it's up and running, as you can see in the log right there, I've got 0 through 7 running. So I've got 8 instances running there.
Now you've got it running, Cameron. Can I quickly mention, I forgot to mention something to you folks. Not only is this working with the SUSE assets such as our container as a service platform and our container application platform that you see here, but but he's also working on our Ceph solution in the background as well. So you may not know, but SUSE deliver an industry-leading Ceph distribution, and we're using that storage in the background of our cloud as well. So all the layers of our software assets come together for you to be able to see this solution driving on our demo cloud today.
It's brilliant, brilliant.
Brilliant. So
It's awesome software. Give it a try. SUSEcon or SUSE.com. You can try this out too. I suck at it. Let's see if you can get higher than 4 steps.
So you might notice a few people wearing these ridiculous outfits around the show. If you want to talk in more detail to us, come over, have a chat with us. We're more than welcoming to you, and we'll be happy to answer any questions you've got. But if you've got a question from the floor, shout them now or forever hold your peace.
All right,
Well,
have a lot of fun.
That's the case. Enjoy your show, guys. Thank you very much. Cheers.